This is question number 28 from section 7.1, MA 259. So now we have the situation where we have been given the Laplace transform, and it's our job to go back into f of t space. So the Laplace transform we've been given is 3s plus 1, s squared plus 4. So when I was in college and I first learned about this, my professor told me that as it turns out in math, very rarely do you get anything for free. And so sometimes the challenge of these Laplace transforms, as we'll see in the next section, is converting them into the Laplace transform is not too terribly difficult because we can use the table. But converting them back can be a lot of work. And so one thing you might have to think about is your trig identities. Another big thing you're going to have to think about possibly is partial fraction decomposition. And you're also going to have to multiply by clever ones and divide sometimes by clever ones. And you may have to add and subtract a clever zero in order to be able to convert these things back. So I've sort of sketched out this conversion back the way I'm sort of thinking about it, but again, this may not actually be the most precise way to write it, but we'll see the more precise way to write it in the next section. So I have this case where I'm given this 3s plus 1 divided by s squared plus 4. And one thing I might be always sort of thinking about when I see these is, well, can I break up this one fraction into two fractions? And in this case, it's pretty easy, right? So I can take this as 3s divided by s squared plus 2 to the squared plus 1 over s squared plus 2 to the squared. And that's the other thing. When I see these numeric numbers here, I think, well, most of those on the chart have a k squared, right? So I convert that to a k squared. So then I took this 3 and wrote it out front. And so I have 3, this 3 out front, and I'm left with the s over s squared plus 4. So s over s squared plus 2 to the squared. And I look on my chart and I see that this is exactly cosine, and I'm calling it k1 here for a second, with k1 equal 2. So I don't want to get this k confused with this other k over here. So this k1, so this should be a 1 right here, k1 equals 2. And so I now have 3 times this cosine of 2t if I transform this part. No problem there. Then this other part. Well, I look at this and I see that that kind of looks like k over s squared plus k squared, which would be the sine of kt. But it's not that, right? It's close to that, but it's not that. So I have to figure out how could I make this to look like this. So remember, I have a 2 here, I have a 2 here, but how do I put a 2 there? So what I did is I just recopied this part over here. What I did is put a 2 there. I put a 2 right here. And if I put a 2 right there, in order not to change anything, I also have to divide by 2. So this is one of these cases where I multiplied by a clever 1, and that clever 1 is 2 over 2. So now I have sine of kt because I have 2 over s squared plus 2 to the squared. But I had to multiply this by a half or multiply the whole thing by a 2 over 2 in order to force this part to become in this s or k over s squared plus k squared form. It was close to it, it looked a lot like it, but it wasn't exactly it. So I forced this to become this form, but in order to force it, I had to multiply this little part over here with a half. So then f of t equals 3 times cosine of 2t, so 3, and the transform, this is cosine of 2t, plus a half times the sine of 2t, and this is the transform of the sine of 2t.